Part 2, using sign lines. If we want to solve a polynomial inequality without graphing, we're going to use a sign line instead. So first write the inequality as a function with 0 on one side. Find all the zeros of f and mark those on a number line. And then choose a test value in each interval that we have on our number line and determine if f is positive or negative in each of these test values. And our solution would be the intervals that correspond to the inequality. So let's try that. Use a sign line to solve 3x times x plus 5 times x minus 7 greater than 0. We already have 0 on one side of the inequality, so now I need to find the zeros and put these on the number line. So 3x is 0 when x is 0, x plus 5 equals 0 when x is negative 5, and x minus 7 equals 0 when x is 7. So I will put these numbers on a number line. And then I need to test a value in each interval. So I'll start with, say, 8. 8 is to the right of 7. If I substitute in 8 into my equation, I have 3 times 8, and then 8 plus 5, and 8 minus 7. And that, whatever that is, it is a positive number. We have 3 positives multiplied together, so it's positive. We don't need the exact value. We just need to know if it's positive or negative. Next, I'll pick a number between 0 and 7. Let's try 1. Then I would get 3 times 5 times negative 7. That is a negative. We have one negative there, makes it negative. Let's try negative 1. So between negative 5 and 0, negative 1 is a value there. I would get negative 3 times 4 times negative 8, which is positive. And then to the left of negative 5, say negative 6, I would get negative 18 times negative 1 times negative 13, so 3 negatives makes that negative. Notice it does go back and forth between positive and negative, and that is because all of the multiplicities of our factors are odd. With an even multiplicity, the graph would touch and turn around, so either stay positive or stay negative. But with odd multiplicities, the graph crosses through the x-axis, so it changes from positive to negative or from negative to positive. Now this asks, where are we greater than 0? So from negative 5 to 0 and from 7 to infinity. Greater than 0 is positive. So negative 5 to 0 unioned with 7 to infinity. Let's try this one. We have x cubed minus 5x squared less than or equal to negative 3x minus 9. So first I'm going to get everything on one side with 0 on the other side of the inequality. So I will add 3x and add 9. Then I have less than or equal to 0. Now I need to factor this. So I can try to find some possible rational zeros, which would be the factors of 9 divided by the factors of 3, and start testing them. So negative 1 works. If I plug in negative 1, I do get 0. So I will do synthetic division with negative 1. So negative 1 times 1 is negative 1, add we get negative 6. Negative 1 times negative 6. 6, add we get 9, negative 1 times 9 is negative 9, add we get 0. So to factor this, I first have x minus a negative 1, and now I'm left with x squared minus 6x plus 9. But I can factor that second polynomial, that is x minus 3 squared. So what I want to solve is this inequality right here, x plus 1 times x minus 3 squared less than or equal to 0. So my zeros are negative 1 and 3. I put those on a number line, and I can test some values. So if I test a value bigger than 3, say 4. 4 plus 1 is 5, and 4 minus 3 is 1. So I have 5 times 1 squared, which is positive. Let's test the value 0. That's between negative 1 and 3. If I plug in 0 for the x's, I get 1 times negative 3 squared, which is 1 times 9, which is positive. And then let's try negative 2 to the left of negative 1. If I substitute in negative 2 plus 1 is negative 1, and negative 2 minus 3 is negative 5. So negative 1 times negative 5 squared is negative 1 times 25, which is negative. This asks where we're less than or equal to 0. So negative infinity to negative 1 is where we're less than or equal to 0. Plus, we are equal to 0 at 3. So I'm also equal to 0 at 3. If it just said less than 0, I wouldn't need to include the number 3, but it says less than or equal to 0, so I need to include the number 3 in my solution.